Here's an example where we're trying to integrate a linear factor divided by a quadratic factor. So it's degree 1 over degree 2, so no long division needed. Normally we would try to factor the denominator, but this denominator is not factorable. One good way to see if a denominator is not factorable is to look at the discriminant, b squared minus 4ac. In this case, that would be 6 squared minus 4 times 1 times 13. So that's 36 minus 52, which is negative 16. The fact that you have a negative discriminant, you might hopefully recognize that that would be what goes under the square root if we were to do the quadratic formula. So under the square root would be a negative number. Square root of a negative number is not real. So that means that this quadratic has no real roots and therefore no factors. So you can't factor it. And so there's really, this is already as simple as it gets as far as partial fractions is concerned. So if you can't factor a quadratic, the next best thing is to complete the square. Okay, we're going to complete the square. To complete the square, we're going to group the first two terms together. We're going to leave a space in there to complete the square. We're going to keep the 13 out of those parentheses. To complete the square, rule of thumb is to look at the middle number, take half of it and square it. Half of 6 is 3, 3 squared is 9. So I'm going to add 9 in there to complete the square. I'm going to also subtract 9 to offset that. That way I didn't actually change the value. After doing that, now what I've got is x plus 3 squared plus 4. Okay. So now I'm dealing with the integral. My numerator stayed the same. My denominator, I'm going to rewrite it as x plus 3 squared plus 4. Okay. Now I'm going to do a little u substitution. I'm going to let u equal x plus 3. That will make that denominator just that much simpler. If I do that, du would be dx. So now I've got on the bottom, I've got u squared plus 4 du. And we do have to be a little careful here, like what do we do with the top? Well, with the top, this x right here is going to be x is u minus 3 by that same red equation there. Okay, so when you do a u substitution, everything's got to be accounted for. Of course, we made the u substitution to make the bottom simpler, but we have to live with the consequences of what does it do to the top. Okay. So my top here is really, it's going to be u plus 2 when it's all said and done. And the way to do this integral is to actually split up that numerator. Right, the numerator was u plus 2. So I'm going to split up the fraction as u over the denominator plus 2 over the denominator. That's the same as u plus 2 over the denominator. We split it up into those two separate parts because each of these integrals is done in a different strategy. With the first integral, now we've already used the letter u, so maybe I'll use the letter w now. I could let w equal u squared plus 4. dw would be 2u du, which is going to work out perfect because if this integral has the u du in there, so that's going to become 1/2 dw. And so this is going to work. This is just going to become the integral. I'm going to have a half dw over, well, let me write it. I got my fraction bar, I got a w on the bottom, and then my u du became a half dw. So see, making that little substitution, now that's just going to be, that's going to end up being a half natural log of w. The other integral, you see, like that same kind of substitution would not work because I don't have the u up here in the numerator, but we do have a formula, right? We're going to use that inverse tangent formula, right? The fact that the integral of 1 over x squared plus a squared dx, it's 1 over a inverse tangent x over a. In this case, the a would be 2, because a squared is 4. So this is going to be, so we're going to have 1/2, whoops. So really the 2 on top, I could factor that out. And then the rest of it, I'm going to use that inverse tangent formula. So we're going to get a 1 over 2 inverse tangent of x over 2. I'm sorry, u over 2. For a grand total of, let's see, so we got a half natural log of w. W was u squared plus 4. But u, remember, u was x plus 3. So w was actually x plus 3 squared plus 4. The second term, the 2 and the 1/2 cancel. And then it's just u, inverse tangent of u over 2, and u was x plus 3. And then we tack a plus c on there, and we got it.